Good evening, everyone. I am your host and instructor, Laney Shaughnessy, and welcome to Spindle TV, your best source for CNC CAD/CAM training videos. Spindle TV is brought to you by Digital Woodcarver, inspiring your creativity and providing you with the tools to create your own unique masterpieces. Hello, how is everybody doing tonight? Hope you all are doing well. And let's see if I switched over properly. All right, welcome Ronald, David, Jimmy, Kevin, and Jim, Ronnie, John and Esther, and John Ryan, William. Wonderful. Thank you guys for joining me tonight. Tonight we are going to be making a marble maze. Now, this marble maze, the reason why we're making a marble maze is not necessarily just for the project. Even though it's a pretty cool project, it's great for kids' gifts or you know, holidays, or just, you know, house games and things like that for around the home. But this project is going to teach us a few things. One, it's going to teach us about working with our grid in the Vectric software, turning on and working with our grid and adjusting our grid spacing as needed. It's going to talk about adding a specialty form bit like our box core bit that we're going to be using to cut the marble grooves, or the ball grooves. We're going to be talking about and making a double-sided project, so we're going to learn about setting up for that two-sided project, and then in general, working with offsets, creating offsets and things of our trail and our maze and stuff. There's going to be, a few lessons in this project itself that are going to be fundamental that we can apply to other projects and things. So all in all, hopefully you can take something away from this and use in other projects, or possibly even make a marble maze of your own. All right, so with that being said, we're going to go ahead and kind of jump into things. Before I move over to the screen, let me show you. Now I'm going to be working with 1/2-inch marble ball bearings here. You can buy a bag like this on eBay for like 10 bucks. These marbles, if I can get one out, these ball bearings and everything, they're 1/2 inch in diameter all the way around. So that's what we'll be using. They come in various sizes, 3/8, 1/2 inch, so on and so forth. And the ones I happen to have are 1/2 inch. So we will work with those. That's what I'm going to be designing this marble maze on. And I've got lots of marbles, so we can have all kinds of fun with that. And one of these days, with some of those marbles, I'm going to make a little pinball games. See if we can knock one of those out one day. All right, so now with that being said, let's go ahead and jump on over into the Vectric software. Welcome, Troy and Donnie. All right, so all right, so in the Vectric, hey, welcome, Mike. In the Vectric software, for the job itself, this is going to be a double-sided job. Now, your maze can be any shape, size, however you want it. You can get creative and do all kinds of things with it. What I'm going to do with mine is it's pretty much going to have kind of a rectangular body in a sense with some handholds and everything. And you can make the maze where it's free and open, like if you dumped it upside down or whatever, the marble would fall out. But since I want to make this as a two-sided maze, where the ball actually will pass through from one side to the other, then we're going to be using or taking some acrylic and creating an acrylic cover for the top and the bottom to secure that maze, like a lid to trap that marble inside, so we can be able to flip this game back and forth. Now, if I was making a single-sided maze, then most likely, I wouldn't have the acrylic top, and we had a single-sided maze at the show for, years, but the marbles kept getting lost. Kids would pick it up and they would, play with it, and all of a sudden the marble would go flying off, and that sucker would roll down the aisleway and you'd never find it again. So we always had extra marbles. But this time, for this year, because I'm actually going to make this for the show season, so if you come out to the woodworking shows this season, you'll see this marble maze. I'm going to have acrylic on it, so it will be trapped and everything. And when I say acrylic, I probably am just going to use like a clear Lexan or something. I don't know if I'm going to go cast acrylic with it or not, because it's just going to be a lid, that's going to have some screw holes and stuff in it. So for this, I'm thinking that overall, on the length, for good comfortability and a fun game and everything, I'm going to go probably with the handles and everything about 18 inches overall. So on my x-axis, we're going to type in 18. And then on the width of the game, I'd like to have it a good size maze area and stuff. And so I'm probably going to go... let's see, what would be too big for a kid's game? I'll probably go 9 inches wide, 8.5 to 9 inches wide. So we'll go 9. Now on the thickness, because this is going to be a two-sided, it's easier for me to take, if I don't have an 1.5 inch thick board laying around or something in the shop, then I can take 2 3/4 inch boards and I can laminate them together. Glue them together and stuff to make an 1.5 inch thick. So that's what the project size is going to be on its thickness. Now for me, and this is all, this next step for the Z0 position is going to be based on you, your machine, your setup, and what you do. You can touch off on the top of the material. You can touch off on the bottom of the material on your wasteboard. Have whatever setup's best for you. Now for me, I work off of a jig. And I have my wasteboard and everything, so I'm going to use the wasteboard as my Z0 position. So for that, I will be working off of the machine bed, and I'm not going to work off the same side, meaning I'm not going to touch off on the machine bed for the first part, and then when I flip the board over, staying on that same side means I'll be touching off on the top for the second part. I'm going to work off the machine bed for both sides. So it's just going to be the machine bed, and I'm not going to have 0 off the same side checked. It's going to be unchecked. And for the XY datum position, because I will be working in a jig, a lot of times it's good to free form it and everything if you want, because we are going to be using alignment pins after all when we flip this project and stuff over. So I don't necessarily have to depend on my fence and stuff, because my alignment pins are going to do that work for me. But I'm going to pretty much go with the bottom left corner for my XY datum position. Now when flipping, are we flipping it along the x-axis, along its length, or are we flipping it along the y, along its width? I prefer to flip along the y-axis, and so that's what we're going to do in this project. Again, you would use the job setup and set it up to your needs and your specifications and stuff. And with that, we're going to go ahead and click OK, and we've got our work area. Now, for this, a lot of times when we're freehand drawing and stuff, a lot of times we don't go into turning on our grid, turning off and on our grid. And depending on your computer and things, sometimes the grid dots are a little light and stuff, and it's hard to see and everything, especially with the background, however it may be. But let's go ahead and, hopefully you'll be able to see them in this picture, or, this screen. Hopefully you'll be able to at least see those grids, spacing and all. Now, the first thing is my marble. I'm going to go ahead and just draw a marble here on the screen. And my marble is, I said, 1/2 inch in diameter. So I'm going to go 0.5 and hit the letter D for diameter to create that 1/2 inch diameter marble. And I don't want my marble traveling in a track that is just tight enough for it to fit into, right? A 1/2 inch groove, like if I used a 1/2 inch box core bit or something. I'm actually gonna go 9/16. I'm gonna give myself a little bit of room. Now, if you guys have 8 or Vectric 8 or 8.5 and you don't have access to a grid or anything like that, which I think the grid was in all the programs. I'm not sure if it's version specific, but you can basically use offsets and things, or just draw your lines out and use your offset tool like we're going to do without the grid. I'm just using the grid because it's going to help me kind of lay out my maze. Now, because I am my marble is a 1/2 inch, I'm going to give myself a little bit of room. So I'm going to go 9/16. I'm going to give myself about a 30-second on each side of that marble so it can freely roll around and stuff and clear. So I'm going to go with a 9/16 box core bit, and that's what I'm going to use to cut the grooves. So what I'm going to do is I'm going to adjust the size of my marble here to 9/16. We'll hit equals, and that'll be 0.5625 in decimal, and let's try that again. 9/16 equals 0.5625, not 0.5625. All right, and that's going to give me basically, that's my marbles inside there plus my 30-second on each side, for that marble maze. Now, what I'd like to have happen is that if my marble was, if I drew a line down these grid points, if I snap to here to here, I'd like my marble, when it's falling down that path, I'd like these grid points to fall right on line with it in case I needed to utilize them for something. I don't need them on these outside lines and things. I don't need those points to be exactly perfect, but I want them. So we're going to go into the Edit menu, down to Snap Options, and on my grid spacing here, we need to basically space those grid points apart by half of their that 0.5625. So I'm going to go 0.5625 divided by 2 equals sign, and that will give me my grid spacing. And I'll go ahead and snap radius. I'm going to go knock it down to about 8 and click OK. And what that will do is, now if I were to take this circle here and snap to one of those grid points, it's hard to see that grid. I'll see if I can zoom out to make that grid a little bit more bold. Unfortunately, guys, you can't change the color of the grid dots. So I apologize about that. But now my grid rows are right along the diameter of that circle. Okay? All right, so that's good for me. Now, before I start laying out my maze and everything, I need to lay out the body of my maze game and stuff, where my handle is going to be and all of that stuff. So I believe that the playing area within this 18 by 9, I'm going to give myself about 2 inches, 2 inches on each end. So I need to go with a rectangle that is, let's make that 16. And on the height, I'm going to go full width. I'm going to go 9 on that. Oops, 9. Come on, I don't know why I'm hitting the minus sign instead of the 9 key today. And then I'm going to take and select this and hit F9 on my keyboard to get it centered up. Now, looking at this, that 2 inches, that doesn't give me a whole lot of room on each side for my handles. I don't know what in the world I was thinking by that. Let's go back in here. And it's 2 inches on each side. Not 2 inches in general, so this should be 14, not 16. Okay, and let's keep this at 9 just for the moment. All right, so this area here, I'm gonna get my handles drawn out, and then I'm gonna create my filled area and stuff. So for the handles, I'm just going to come in and a comfortable grip if I'm holding this game and stuff. I think about 3/4 of an inch or so. Let's see here. If I go 1 inch, that'll give me a 1/2 inch on each side of meat around the edge, and that's not bad. You know, if I go a 1/2 inch wide, but, or, you know, 1 inch wide, sorry. But I don't know, it might be too big. So let's go with a 0.75 inches wide. And of course, it's something that you would make an adjustment on, you know, as you go. Now my hands, you know, they're not big at all, you know, so I'm a little guy, but you know, across my palm, my hand is only 3.5 inches wide. And I'd like to have a little clearance. I don't want my fingers being all tight and stuff up in there and everything. So I'm going to go about 5 inches wide and 5 by 3/4. And let's go ahead and get that centered up. And now as far as the placement and everything, I want to pretty much center it within this area. And so what I'm going to do is I'm going to draw a rectangle here. And I'm going to select this rectangle, the little handle hole first, and then this rectangle. And I'm going to use my alignment tool, and I'm going to align that center of itself, which it was pretty much there to begin with. Now, I don't want the handles being square like this. I want them to kind of radius, you know, around and everything. And I could do, you know, radiused corners and everything, but I actually want them to be almost like a long, elongated oval. So I'm going to, first off, I'm going to shorten this up, this handle hole here. I'm going to shorten this up to 3.5 inches. And then I'm going to come in to here in node editing mode, and I'm going to come in and I'm going to change this to an arc and just let it go to its full arc. Down here at the bottom line as well, let's zoom down so you can see that. I'm also going to right click on that, and I'm going to change that to an arc to create my handle hole and everything. And now I'm not going to have just this square body, you know, here and being looking all boring. We're gonna do some curves and everything when I get into you know, this. We're gonna get into some curves and all to create the shape of our overall. But I'm gonna take this now and I'm gonna select both of these vectors, and I'm just gonna mirror them to the other side. Now that I have everything placed here, so I'm gonna open up my mirror tool under transform objects. I'm gonna create a mirror copy, and I'm gonna flip it about job center, and I'm gonna flip it horizontally to that other side. Okay, so far layout's pretty simple, right? We're not getting into anything too technical here. Now I want to figure out my overall shape. So I am going to have a straight body along the length, you know, the majority of the length where the play field is going to be. But I want it to kind of come in and almost radius, you know, to this corner. I want to kind of get rid of that sharp corner in a sense. And so one of the things that, you know, I can do here is if I take and draw a rectangle all the way across my box, snapping to this top corner and then this bottom diagonal corner and everything, I'm going to create a radius edge on that, and I want a nice size radius, so I'm probably going to go about 1 1/4, and let's go ahead and click apply. Nah, it's too small, so let's go big. I don't want it to be small. I'm going to go let's go with a 3-inch radius. Okay, there we go. It's looking good. So I like it. I think the 3-inch radius will be fine. Let's take a look at what let's give it another inch on there. Let's go 4. Let's see what that would look like. Okay. I'm going to split the difference on that. I'm going to go 3.5 because I like the 4, I like the 3, but so that means 3.5 is going to be perfect for me. There we go. Okay. So now that I have that, you know, this is going to be my profile vector here. And so what I'll do is we're going to kind of start teaching you guys layers. A lot of you may already work with layers, be proficient with it and stuff, but we're going to work with layers. We're going to start kind of separating some things. So what I'm going to do is I'm going to right click on this selected vector here, and I'm going to move this to a layer. And this new layer is going to be called my outside profile. And I'm going to give it a color of red. Okay, so we can see that outside profile here. For my handle holes, I'm going to go ahead and select those, and we're going to right click and we're going to move those to their own layer, a new layer. And this is going to be my handle holes. And we'll give them, we're going to be patriotic, we'll give them a blue, a dark blue color. All right, we're getting somewhere now. All right, so now that we have our handle holes and everything, now I need to focus on the play area and everything. And so I want to have a good size wall, you know, around within my area here, because of the simple fact that I'm going to be pocketing this out and creating a lip for a piece of plexiglass to go into and everything. And I want to have enough, you know, I'm going to be using tiny screws and things, and we're going to lay those out as well. But I want to give myself enough meat, you know. So I think what would be best is to offset that inward. Let's see here. Let's see, 1 inch. If I pocket that lip around, let's go 1 inch. I'm going to delete the original. I don't need that original border there anymore. And 1 inch is a little bit too much. Let's go ahead and let's go 0.625. And that'll give me enough room for screws and everything. So that's going to be my play area there. Awesome. All right. So now we've got, we don't really need these outside profiles here and here, or outside rectangles and all. And so this is going to be my game area, and it's going to be the same on both sides and everything. So what I'm going to do is I'm going to select all of these vectors, and I'm going to copy them to the other side. Okay, that way my top and bottom, you know, they're going to be the same. Create my play area. Now my play pattern, that's going to be my play pattern and everything. That's going to be different. You know, the path, the marble path is going to be different on both sides. We're going to make it a challenging game. Now, Ronald Sands, to pause for a question a minute, says, can you reduce the height of the handholds to 3/8 sides to make the handholds 3/4 of an inch thick? And I'm not sure, Ronald, if you asked this question before I did it or after, but can you reduce the height of the handholds to 3/8 inch each side to make the handhold 3/4 inch thick? And so you're wanting the handhold here from the outside edge to the inside of that hole where your fingers go to be about 3/4 of an inch thick. And let's see where we're at right now. If and make sure I'm correct in that statement that I just said. But if we were to measure this horizontally from here to here, we're about 5/8, so under 3/4. Now, if you wanted to go 3/4, we could bump these in. You know, if 5/8 was a little bit too narrow, you got to think about, you know, what's a comfortable grip and stuff. We can always bump this over to the right 1/8 of an inch. And so let's do that so we can see how that would be done. We'll take this one and we're going to move it relative to its position on the x-axis. We're going to move it over an eighth of an inch. And then same thing with here. We're going to move relative, and this is going to be, we're going to the left, so we're going to move negative 0.125. Okay. Now what that means is on my other side here, we've got to delete these guys, and then we're going to recopy these two vectors over to the other side. Okay, so that way everything lines up. If you make any changes, since we've kind of put it on ourselves and we copied all of these vectors as they sit now to the other side, then if we make any changes, any design changes over here for anything, we need to make sure we update that other side as well. Ronald, let me know if that answered your question. Now we are, we've got a 3/4 inch basic handhold, kind of grip area here from the outside edge to the inside of that handhold. We'll have that 3/4 inch grip. And I'm going to be doing some round over and everything here to smooth off the edges and stuff. So that should help as well. Oh, you're talking about the game board thickness? Well, think about this, okay? Let's think about that. So on the game board thickness, so I have a 1/2 inch marble, right? And I've got on that marble, my marble maze. I've got a lid, right? I've got a lid that's going to be, a plexiglass lid and everything that's going to be over here. And that I'll probably use 1/8 inch. So let's go ahead and let's do this to scale. Let's size this on the height, 0.125. Or I'll probably do, 1/8 inch. All right. And let's take that and snap that to there. Okay. Now my marble is actually going to be in this 9/16 inch wide groove, but it's also going to be 9/16 of an inch deep. I want the marble to be within that groove completely. So let's go ahead and take that marble and move it relative to its position, not size, move relative to its position on the Y down, negative number, negative 0.0. Oh gosh, I stumped myself on this one. Bear with me a second. 0.65. I was like, wait a minute, what did I just say here? Okay, so I'll have my groove and all, and then of course that's where the bottom of my groove is going to be. The bottom of my groove is going to be here. Let's get one thing about those snap points and everything is let me turn that grid off for a minute while I'm freehand drawing. Those points it wants to snap to all of them all the time. So that's where the bottom of my groove is going to be, there. Now I want some meat, right? I want some meat between here and everything. Let's say that we be, somewhat generous. Give ourselves about, I don't know, 1/4 inch. Quarter inch you may think is a little thick, I'm not sure. And then of course all of, let's take and draw a line here, right there. And we're gonna take these two objects and we're going to flip them about that line. We're gonna mirror flipping it about that line. Okay. And so now if I were to take and get a measurement of my overall height, I'm about 1.625, Ronald. Okay. And so the 1.5 inch means that the middle area where my grooves and all is going to be, about a a 32nd inch thinner on each side, so you know, a 16th of an inch thinner. I'm sorry, an eighth of an inch thinner on each side. So I'm not going to have a whole lot of meat. So it's something I've got to think about and everything. Now you're saying just reduce the handholds to 3/4 of an inch. Yeah, I mean, if you want to mill down and have it kind of swoop down to 3/4 of an inch, you can do that as well. However you want to do. You can create a pocket area here that mills these down, you know, on each end to you know, where it'll step down into that or gradually slope. You can do that as well. So yes, to answer your question, you could. But the reality is I need an 1.5 inch thick material for the gaming area at least. As far as reducing this down, we can look at that when we get to it. We can look at, you know, how we would create the pocket cut or cut to kind of reduce the thickness of this area and stuff here. We'll look at that for sure. Now, if I had a spire, I'm working in VCarve Pro and all. If I had a spire, then I could draw a model to create that shape or curve so it's a nice smooth curve, or I could just step it down and then I could sand it if I wanted to, all of that stuff. So we'll look at that. All right, so let's get into the game area here. Now, this is where you just get creative, okay? So basically, I've spaced my dots, my grid apart, my grid's points and everything apart, to a fact that where when I draw on a line, then the line on the left and the line on the right of that is going to be the width of my groove when everything is said and done. So now it's just a matter, we're going to use a polyline tool and we just kind of you know, start laying out the maze. Now up here I'm going to probably have a start point, and I'll probably end up doing a little VCarve text or something that says start, you know, most likely. But so let's give ourselves a little bit of room and let's start kind of drawing this out. So I'm going to have not only the main course, but I'm going to be drawing in some traps as well. And so let's just kind of start laying things out. And this is where you just, you know, be as creative as you can, as you want to be with your path and stuff. And right now I'm just kind of drawing a kind of a main track, should I say. And let's see. And there's no rhyme or reason. I don't have anything pre-planned or laid out. I'm just freehanding it right now. We're just kind of drawing a trail of sorts, and I want to utilize my snap points, so I want to make sure my lines go all the way down to my snap points. And let's see here, let's go I gotta be mindful of where I'm going and everything, because I'm going to be offsetting this line out to each of those rows. So I got to look carefully and make sure that I'm giving myself enough room, and we'll find out. It'll tell me in a heartbeat when I do the offset if I'm having, you know, any conflict or issues and stuff. Let's see. Let's go down another row, over, down, and again, just, you know, give your be creative. Let's go. I've got to be, I'm going to undo that last line here and undo that last line. That's the wonderful thing about the polyline tool, because I want to come here. Actually, I want to come one row up. Bear with me a second. Okay. So, and again, this is just kind of the main trail. It's not that, it's not that difficult. It's not a challenging puzzle right at the moment and everything. But now we're going to come in and we're going to create some traps. Let's see here. Places that the marble could go and get stuck. I don't know about that little nub there. We'll we'll delete that one in a minute. All right. Let's see here. I don't want to make this class too boring with you guys watching me draw a bunch of lines, so we'll get to the fun stuff here in a second. Let's undo that. I want to use my grid as much as I can to help me, create things. And let's see here. All right, so let's imagine that this is our maze, and I'll probably end up going back and kind of looking at things and stuff. Now what we need to do is, this is the maze, but it's not our cut. We have to create pockets. We got to create our closed vectors, our rectangles and everything to create the pocket cuts for our marble trail and everything. And in order to do that, we need to offset these lines. And so we're going to come in and I'm going to offset these lines. And what I'm going to do is first, before I offset them, let me take and make a copy of this or move this to its own layer. And I'm going to call this the marble trail. And we'll make this, we'll go green. And then we're going to create a new layer. We're going to call this our marble trail machining layer. This is going to be the vector that we're actually going to create the toolpath off of. And with that active, we'll go ahead and once again, we'll select all of our vectors. We're going to offset, and this time we're going to offset in both directions, okay? And I want to offset, since I'm offsetting in both directions, and I'm going 9/16, right? So, but I'm going half of that, because the overall width for both of those lines, the space between them is going to be 9/16. So I'm going to end up taking and dividing that by 2 to get my, decimal point, 0.2812. And I'm going to keep the original, and I don't want to keep sharp corners because I want that marble to be able to kind of travel around the corner and everything. So I'm just going to go ahead and offset this to create my marble trail. Okay, so now it's starting to look like something. All right, now one of the things that we need to look at is our trail and everything. Did we create a trail in an area where our offset got cut away? So as you see here, from here, this line being offset in this direction, and from here, this line being offset, from here, this line being offset in that direction, they kind of canceled themselves out. So it ended up creating this big void right here. And I believe that is the only area that did that. So I have two choices. One, I can leave this void here, and when my marble goes in here, I could do some V carving in here, thinking, saying that, wait 1 minute before moving on, and they have to literally make the marble stay in this area for a minute before they can continue on, or whatever. Or I could just fix it. Either one. Now, in order to fix it, is what I would end up doing is I'd end up just changing my trail path. I'd probably bring my trail down 1 row here. So if I take and go into, let's go ahead and select our offset. Let's turn everything off for a minute. So all we're seeing is the marble maze itself. And if I select and just get rid of that for the minute, I can turn my trail back on and fix this area. And the way to fix it is I'm going to take my nodes, I'm going to go into node editing, and I'm going to delete this point. That extra point doesn't need to be there. But I'm going to take this node here and this node here, and I'm going to move them down 1 row. Now I could do that simply by just dragging this and snapping like that, or I could use my down arrow keys, however I want to do. But that's really all I needed to do for this. So now I can go back in and let's make sure that we're still good. Alright, so now I can go back into selection mode and I can select these vectors and just redo that offset, okay, to fix that trail there. Alright. Now, same thing here. Okay, we have another void. Again, I could utilize that in the game somehow, or I could just fix it. And the fix for this, because this line went offset this way and this line here went offset this way, canceled themselves out. To fix that is I would just move this line down a row. So let's undo what we just did and let's fix that. So we'll go back into node editing, and we'll take and hold down the shift key and select these 2 nodes, and I'm just going to grab this node and just drag it down and snap it to that point there. And then with everything still selected, I'm going to just recreate that offset. Okay. So now I believe I'm good and I don't have any more issues as far as big voided areas and stuff. I've got my 9/16 inch trail running all the way around. So we're good there. Now all I have to do is clean up my pockets, open up my paths and everything. We got to do a little bit of trimming and then close off our vectors. So I'm going to turn off the main trail. Okay. And let's close the offset tool here. And now I can go in and start kind of cleaning up. Now this trail here, looks like it's running into that, which is fine. It's not hurting it and stuff. But before I do anything, I've got my marble's going to be rolling. And it's going to be coming around and everything. I've got a nice curve here, but on this inside corner and on this inside corner on that curve, I have these sharp points and stuff, and coming in here I've got kind of a sharp point as well, and I want them to be nice and clean and smooth. So what I'm going to do is I'm going to trim together my trails and get them all together and everything, but then I'm going to do some offsetting of the whole thing to kind of create that radius there. Now I could very simply, if I wanted to, use my fillet tool and create a radius. If I look at the size of this radius here, if I were to measure using the dimension tool, an arc dimension, I have my radius. And so I could match that with my fillet tool. I could open up my fillet tool and come in here and say 0.2813. And I could come over here and, give myself the radius as well. So I have that corner and everything. But I'm going to use the offset tool on the whole thing to do all my corners at one time instead of having to go click, click, click and find all my corners and stuff. But before I do that, let's go ahead and kind of clean these lines up and stuff. So I'm going to go ahead and we're going to use our trim tool, and I'm going to go through and start trimming away these lines and opening up these valleys and things. So we're going to trim away these lines, creating our path. Okay, and I believe this is the last one here, and I'm good to go. All right, so now this trail comes all the way here, and then it comes back and dead ends there. Now I'm gonna end up closing that off in a moment, but before I do, I want to do my offsets. So now if I take all my vectors, if I select them, and I go into the offset tool, and I've got my offset in here. The first thing I'm going to do is I'm going to offset outward, and then I'm going to offset back inward. So we're going to delete the original, select the new. We're going to offset outward first, okay? And then we're going to offset inward. Oh, you're not going to do that for me. That method might not work in here. It works with my puzzles. Let me see here. Let's go inward first and then outward. Okay, that's not going to work, so we can't use that. So we have to use the fillet tool. That's a shame because it's a nice feature when doing puzzle pieces and things, when wanting to be able to take and offset all of your vectors. You do a process of offsetting in one direction and then offsetting back in another, and it will round off all of those corners to the radius that you want. And it's a nice function, especially with making jigsaw puzzles and things. But unfortunately, it's not going to work here because of the fact that we can't offset inward and things because we lose our trail. Dadgummit. All right, so what that means is we got to step back and punt a little bit, and we got to use our fillet tool. And so when coming in, now for the most part, coming in and falling into here, it doesn't really matter if these corners are radiused, for the most part. But what does matter is on these inside corners like this trail and stuff here, I definitely want, that raceway to be, kind of opened up. Now, when you think about what I just did, if we come in here and let's undo that for a minute, and let's measure for a second. Remember, we have a 1/2 inch marble. We've got 9/16 inch cutting depth, width. Well, if I come in here and measure to the center of this, I'm pretty well. Let's snap to that corner and then to the center of this. Okay, I'm well within, 0.6525 is 9/16. I'm well over that, so I really don't have to mess with the corner if I didn't want to. If I didn't want to offset it or anything, I don't need to. I've got plenty. My ball bearing is not going to get stuck. I just like the smoothness of having this rounded a bit. And maybe on the inside corners, we don't have to go the full 2/8. Maybe just a small amount, just a small radius to turn that corner. However you want to look at it, however you want to design it, that's totally up to you. I will use a fillet, and you know, let's go smaller. Let's go with a 1/4 inch radius, or 0.1875, however we want to do, and you know, just create that gradual corner. You know, that gradual corner, just to let that marble be able to get through and stuff. So let's come, if we were coming around here, let's click on that. There. Okay, if I was coming through here, coming around this corner, this one won't let me radius, so I'm going to have to go straight wall on that one. All right, now I'm going to have to choose on this one here. Again, smaller radiuses. I do want it to be rounded. I don't want it to be square because I don't want a sharp corner there. So let's go with a smaller radius. Okay, and you know, just create that. And I'll probably reduce these that I did a moment ago. I want to keep everything somewhat consistent. So I'm just finding all my corners, and it's a shame that tool didn't work with the offset, because we'd have been done with this part by now. All right, let's see here. So an 1/8 inch radius is giving me everything that I need for my trail. All right, now we've got to close off these vectors and join them together. And I'm going to join them with a straight line. We could use a smooth curve and kind of round them off and everything, but I want to be able to do my own radius, so I'm going to join them with a straight line. The vectors, I'm going to close them off, and same thing here and here. Now the end of this vector is up here, and so if I select this one and join with a straight line, it'll close that off. And when I radius this edge, that'll pull that away from let's see if I can get on that corner there. Not much. It's not going to give me a whole lot of wall there. So let me rethink this area here for a minute while I'm going through and getting my corners done. All right, let's join with a straight line. Let's see here. I most likely want to radius that one the full. And I don't know why I can't remember that number off the top of my head. Oops. And I'm just doing math in the boxes and everything. Just doing math. Come on, I want that little check mark pop up there, buddy row. There we go. All right, gonna go back to my 1/8 inch radius. And let's close off the rest of these. So we'll take this one here, this vector here, join with a straight line. This vector here, join with a straight line. This vector here, join with a straight line. This vector and this vector will join with a straight line. And the same thing here. Now, of course, I could get tighter and things if I used a 3/8 inch marble versus a 1/2 inch, or so on and so forth. Join with a straight line, and then finally join that in with a straight line. So it closes everything off, and now I can go through and I'm going to end up radiusing that full dadgummit, 2817 I think it is, but I keep forgetting. So 9/16 equals, divided by 2 equals 28125. I got to remember that in my head. I'll go ahead and radius these little nubs and stuff off. Okay. So this would definitely be a age 3 and older puzzle. It's there's not a whole lot of complexity to it. I mean, looking at it, there's not a whole lot of complexity to it. But I have a start point over here, and then I'll have a finish point, which is a flip point. And right in here is where the ball's going to fall to the other side, and then we're going to continue that to the other side. Now, you could make it a start to finish here on the front side where there's a trap, where it falls through, like there's only like just barely a little bit of meat to get around the hole or something, and it falls through. And if they get to the other side, they have to go through a maze just to get back, flip it back over to start over again. You could do all kinds of creative things. I'm not that creative right at this minute, so we're not gonna do that. We're gonna just at this end point here, we're gonna finish, and then they're gonna work their way back to the other side, to the finish line on the other side. And so I'm gonna create a layer here for my flip hole, and make that active, because I'm just gonna draw this in. That's where my pocket is going to be. All right, and I'm going to copy this one to the other side, because that's going to be an important one. My hole on the other side has to line up with that. All right, so now I think you get it, right? As far as creating that and creating your maze, you can get as creative as you want. Use smaller marbles. You can get closer, tighter corners and stuff, and come up with a few, you know, little more trouble areas and stuff right now in my play area. My marble is big, and because I'm only going 9 inches wide versus wider or something, I don't have a whole lot of playroom. You know, there's not that much room to give me, you know, much to go on. So now Ronald jumps in with a couple more questions. Can you do a crisscross or an intersection? Yeah, you can. So, Ron, that intersection, it would be, imagine if I came in back where I was. Oops. Let me do it this way. You know, if I had an intersection here that came out, and let's go bum, 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 bum. And use my scissor tool, then I can end up opening that up, you know. So now that gives, you know, a shortcut to the finish line versus going all the way around to the finish line. So there's kind of a two ways to go about it. You know, so yes, you can do an intersection however you know, need to and stuff. So, you know, there's a couple of areas we could probably connect together. What I would say is, let's undo that intersection there, and let's come up here and do an intersection here. Bum, 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 bum. And then let's give ourselves a little bit of radius. Oh, not that much. Lord have mercy. And so now that would give an alternate path again, you know, not so close to the finish line, but that would give an alternate path versus coming all the way around here, which will still get them to, there's two ways to kind of get through there now. You know, so yeah, I mean, there's all kinds of intersections and things that you could do. You could really maze this up. Now, I'm sorry, that wasn't Ronald, that was Kevin. Kevin asked that question. Sorry, Ronald, I thought it was you. But yes, so we could do intersections and stuff. Now he's got me thinking about intersections. Let's. Okay. All right, so now let's create some toolpaths on this side. One of the things I have to do is, remember, I'm going to have some plexiglass, so I got a pocket cut and stuff. So on my rectangle here, I need to offset it first, and let's create a new layer. We're going to have lots of layers that will probably end up summarizing and things, but this is going to be my rename. This is going to be my cover. Plexiglass cover, let's go cover pocket vector. And let's give it a nice little old plum color, I guess. All right, so we're going to offset this outward, and I want to probably, so I have my screw holes and everything, I'm probably going to go a good 1/4 inch around. Okay, this will be my lid here. You know, and if I you know, I kind of want round corners on the lid for organic, you know, curves and all. But if I didn't want to take the time to have to, you know, cut the plexiglass, because I'm gonna, you know, I'll probably end up using the CNC to cut it out anyway, so that'll be good there. And let's take our filled area. We'll change this vector on the other side. Remember, it's on the other side. But let's take and get some corner radiuses on that. So I'm going to offset outward that 1/4 inch, and then I'm going to offset it back inward a 1/4 inch, or actually backwards. I'm sorry, I'm backwards. Dadgummit, I'm backwards. I'm trying to show this stuff. I'm going to offset it inward and then back outward again to create that rounded corner. That's what I was trying to do earlier, guys. That wasn't working. So now I have nice rounded corners for my board area. All right, so this is going to be a pocket area. It's going to pocket everything down that 1/8 inch before my grooves and all get cut and stuff in. It's going to pocket everything down for that plexiglass. And then, of course, I've got my play area that's going to be cut with my box core bit. We've got a 1/4 inch end mill that's going to be doing our handles. We're going to have a 1/4 inch end mill doing the profile cut. And then we're going to do a round over. I'm going to take a round over tool. Right now, the only round over tool I have is the Whiteside 2750 or 2050, which is an 1/8 inch round over, which will be good just to give a nice, so it's to break the corners, you know, to break the sharp edges and stuff. So I'll use that wherever I can on the outside and stuff. One of these days I'll pick up a larger round over and stuff. And then I'm going to have a drilling or pocket, however you want to look at it, drilling toolpath, a pocket, not drilling. I'm going to have a pocket toolpath going all the way through to the other side, and you know, we're going to have the same thing. So what I need to do is on the other side, I need to delete this vector right here. And then I need to take and select these two vectors and copy them. Copy. Before I copy them, I want to think about something. I'm going to be using very small screws. This is going to be the plexiglass here, and this is the only bit of meat that I'm going to have to screw into, and they're going to be small brass screws. They're going to be countersunk and everything. Let's see what that width is to make sure that I don't have to offset this out just a little bit more. Let's see what that width is. We're going to go with a vertical measurement from here to here. Man, the little brass screws that I'm going to be using, I'm going to take this vector here. I'm going to go just a little small amount. I'm going to take this vector here and offset it outward, deleting the original. I don't need that. I'm going to offset outward just another 1/16 of an inch, or maybe 32nd. Let's go 16th. There we go. Yeah, that's good. All right, now I'm going to take these two vectors here and I'm going to copy them to the other side. All right, and if we flip over to the other side, now, you know, you can see the vectors on this side where the game trail is and all. And of course, you can make a completely different trail. you know, you're starting here. You know, when that marble flips to the other side, it's going to come through here. And then you're basically going to be working your way back to wherever you want to work your way back to, you know, your finish line. You're going to have start on the front side, flip, and then finish line. For time's sake, you know, I think you guys get it on this. What I'm going to do, just for preview purposes only and everything, I'm just going to copy this vector here, all of this. To the other side, because I think you get how to make the trails now. Copy to the other side. If you don't, let me know. That way we have our path and everything, and they've got to get back to, you know, their finish line. And actually with this one, there's 2 trails to get back to that finish line. They can go 2 ways with it, you know, so good on them. All right, let's create some toolpaths and let's see what we're doing here. But we got to, hey Wayne, how are you doing? Welcome. We got to think about something. We're flipping this board, right? We are flipping it, and then we're you know, cutting things out and stuff. And also, where are our alignment holes going to fall and everything? And usually, I like my alignment holes to be somewhat, you know, near the center and all, but in this case it's not necessary. We don't need that. We've got we're using asymmetric holes, meaning they're not in line with one another. So I'm going to draw my 1/4 inch alignment pin hole right here. So I'm going to go 0.25 D for diameter. All right, and also think about the placement of that hole. If you're wanting to screw this down to your wasteboard for some reason, for, you know, securing it and everything, if you feel that, you know, if you're worried that the clamps would move, you know, when it's carving, you know, these pockets and all, 9/16 inch deep pockets and stuff, or if you're worried about something moving while it's carving and you want to like secure it down, then make sure your alignment pin holes aren't in a place where you're going to put your screws, you know. And I've got plenty of room to screw over here if I wanted to, you know, to secure. But my alignment pin hole is going to go right there. And over on this side, wherever Heart Little desires, we're going to go here. 0.25 D for diameter. Now I'm using the keyboard shortcuts. I could use the menu and just type in and click apply, but I'm typing in what I want, and D for diameter on the keyboard, or R for radius. However you want to do it. Now these are my alignment pin holes. We're going to go ahead and select them, and we're going to copy them to the other side. Now we are officially ready to make some tool paths. So let's get rid of that. I think you guys kind of got what I was trying to illustrate there, as far as why we're going with a 1.5 inch thick board. And then Ronald, we'll come back after we calculate toolpaths. We'll see about, you know, thinning this out, you know, creating a vector that will allow this to machine, you know, smoothly, whether it be a molding toolpath or something, just to kind of get that transition where it thins up these holes a bit. If somebody, you know, 1.5 inch thick, you know, don't want to be grabbing it so thick and all, we can. And when we round over these edges, we could use a larger round over, right? On a router table or a handheld router, we could round off these handholds much more than my 1/8 inch, and that's going to reduce this area significantly on both sides, especially if we round over the edge the same way, which I don't have a whole lot of room here for round over where my plexiglass is going to be, so that's why I'm using an 1/8 inch bit. That, and I only have an 1/8 inch bit, right? So, all right, let's create some toolpaths and quit all that yammering. Lord have mercy. And then we'll get into some questions and stuff. So for this, let's start with the trail. And with this, we have to, I don't have a box core bit, a 9/16 inch box core bit in my tool database, so I have to add one. Now, the bit that I'm referring to, if we were to pop open a web browser here, I know Lowe's sells 1/2 inch and 3/8 and things like that. I want a 9/16 inch box core bit. And the I believe it's this one right here. This is the box core bit that's going to be used to create the grooves, and it's got a 9/16" diameter. It's got a 1/2 inch shank, real sturdy. So because I'm going to be carving in hardwood and everything, and so I want a bit that's got a little bit of beef. Now that it does have a little bit of a price tag to it. This is a $50 bit. Now if you're using marbles, general marbles are around 3/8 of an inch diameter and stuff. You can get yourself a 1/2 inch diameter box core bit from Walmart for like $21 and things like that. But this is the bit that I'm going to be using. It's not the only 9/16" bit out there in the world. There's cheaper bits and things like that. But this is the one that I have that I'll be using. All right. So I have to draw out that bit. I've got to draw this profile out so that I can add it to my tool database. It's a form tool. So if we look here, D, for diameter, overall, the little d, it's a 1/2 inch shank bit. I don't need any of that. I need this information here. So the D overall diameter of this cut is bear with me a second. Where's my friggin'? It's a 9/16" diameter, but do you see it listed in this list right here? No. Isn't that just the funniest thing in the world? Let me see what tool number they gave it. 45934. Diameter 3/16. So let's look and see how creative these lovely folks are. 45934. That's not even in the list. It might not be in the list. Oh, that's other sizes available. I'm sitting here thinking, now, wait a minute. What's going on there? And I was thinking, what in the heck? Now, if you don't want to draw out the profile, Amana Tools does something cool. They have DXF files of the profile bit. If you create an account or log in, you can download it, import it into your software, and then you can add it to your tool database. A little less fuss and all. Love that about them. But they had me going there. I was like, wait a minute, that's not even in the list. So overall diameter on this is 9/16. The radius is going to be that 0.281, whatever it is. So let's go ahead and 9/32 if you want to be exact. So let's go ahead and draw this out. We're going to go into our drawing tools, and I'm going to use a rectangle tool to help me out with this. Now, the one thing that is the height here, B, the cutter height, that is 1.25 inches. So you got some good depth in there and stuff, which is good. We're not going to be cutting that deep with it, but it's a nice deep. Most box core bits don't have that much, cutting depth and all, but 1.25 inches. So pretty cool. All right, so we're going to open up our rectangle tool, and on the width, that's going to be 9/16, which is 0.5625. Got that down already. The height is going to be 1.25, and the radius, external radius, is going to be that 9/32, which is that 0.28125 we've been working with throughout this whole thing. And so we're going to go ahead and just click here and create that. Okay. I'm going to turn on my fillet tool, and with that 0.28125, I'm going to come over here and remove this corner. I don't care that it slanted it down. I'm going to remove that corner because I'm going to go into node editing mode. And I'm going to delete this span here, and I'm going to cut the vector here. and then I'm going to delete that left side. All I need is the right side profile of the bit to add it to the tool database. Add a form tool to the tool database. You've got to draw out the right side profile of the bit. So in the tool database, with that selected, you got to have your vector selected before you open your tool database. We're going to go into new, and it's a form tool. Okay, so it'll draw out the tool and put in the diameter here. It's going to give you some recommended pass steps and stuff and everything for the step over. I'm going to adjust the step over a bit. I'm going to reduce it down, and I'm going to go 33 1/3 of that for the step over, because it's not stepping over on that particular cut, but that's the one I wanted at. Now on the feed rate of this, I'm going to probably run this bit about 55. I'm going to plunge about 15. Now, if I had a spindle, I would probably be between 16 and 18,000 RPMs with this bit and everything. But on my dial on my router, I would turn it down. I have a router, I don't have a spindle, so it's controlled by the 1 through 6 dial. So I'm probably going to be between 3 and 4 on that Makita or Hitachi dial and everything for the RPMs. I want to be between 16 and 18,000 RPMs with that. So we're gonna. This is gonna be my 9/16 box core bit. I'm going to add that to my tool database. Now I can create my toolpaths. All right. So, and guys, if you ever, for whatever reason, anytime I create profiles of bits and stuff, I export those out as a DXF file. And I have a folder of DXF files in case I ever lost something. It's on my backup drive and stuff. If I ever lost my computer or crashed and I had to reinstall my software, if I needed to re-add those bits in, then I can pull those DXF files off of the flash drive to bring them in and just quickly add them back to my tool database, so I didn't have to redraw them again. So keep that in mind. And when you trace pictures, when you trace a bitmap and stuff, save those the bitmap of that picture. Export that DXF out of your Vectric software under File, Export, DXF, and export them out, so that way you can bring those into other projects and you don't have to trace that picture again, right? Only one time. All right. Okay, I'm going to take a sip of Dr. Pepper and we're going to move on. All right, y'all still awake out there? Give me a heck yeah, hey yeah, I'm here, or all that in the chat room. Let me see you're alive. If you got any questions that you want to ask, start typing them now. And as we go through these toolpaths, we'll go into, after the toolpaths, we'll create and answer the questions. Now, my first toolpath is going to be my alignment pinholes. I always put that at the top of the list. And so we're going to go in, and this is going to be a drilling operation. It's going to, in this, I'm only drilling about 3/8 of an inch to a 1/2 inch in my board. If it was a 3/4 inch board, it'd be 3/8. With this being a 1.5 inch board, I'm just going to go a 1/2 inch deep. I'm going to be using my 1/4 inch end mill for this, and I am going to use pecking. I want it to come down and pull those fibers out. I don't want it just plunge down. You can turn pecking off if you want, but that's just going to, the bit's going to go down to a 1/2 inch and come back up. I like to peck to clear out those, especially because I'm going to be carving in hardwood. So this is going to be my side 1 alignment pinholes, and it's going to be a 0.25 end mill, and we'll go ahead and calculate that. All right, we're getting there. Let's get rid of that solid color and let's go to a nice little cherry piece of board there. And if we were to preview that, look at there, 2 1/2 inch holes. All right. Now we're going to go ahead and I'm going to do the pocket for my, because all this is getting pocketed out. There's no sense in doing the trail until that pocket's done. So that's going to be this outside vector here. And this is going to be pocketed down just the thickness of my material for my, whatever I'm using for my cover. And I believe I'm going to use 1/8 inch. So then my pocket depth is going to be 0.125. If you wanted it a little lower or what have you, that's fine, because think about, you know, even though my little small brass screws are going to be countersunk, you know, in there, and they're going to be flush with the top of that. If you didn't want, like if you wanted to just in case they didn't sit nice and flush in those countersunk holes, but you didn't want them kind of protruding over the top, you can go, you know, 0.126, 127. You can give yourself a little, yep, 1024, Dr. Pepper time. That's right. 10, 2, and 4. But you can give yourself a little depth. I'm just going to go 1/8 of an inch, and we're going to do an offset for this, back and forth, or round and round, should I say. I'm going to be using, in this I could use a wider end mill for faster cut, but I'm just going to use my 1/4 inch end mill. I could make it faster with a 1/2 inch end mill, you know, knock it out. I could go with hell, I could go with my surfacing bit for all that, my 1 1/4 surfacing bit and everything. Now, of course, that would change my radius dramatically, right? You know, in these corners. I'm just going to go with 1/4 of an inch. And this is going to be my cover pocket cut. And it's a 0.25 end mill. That way I don't have any bit changes between those two steps from the time it drills those holes till it goes over and cuts those pockets. It's all the same bit, and I don't have to change them. So, you know, that pocket will get cut out. 10, 2, and 4. Isn't 6 in there somewhere, David? 10, 2, 4, and 6. Or did I just throw that in because I like drinking Dr. Pepper? All right, so let's turn off that black. And so this is the pocket where our little plexiglass is going to go. All right, awesome blossom. All right, now when that pocket is getting cut out here, this vector really doesn't play a role unless I wanted, you know, to have my pocket drop down even further. So this vector is, you know, just to kind of outline my play area and stuff inside wall. So we're not going to use that one at all. So now that means we got to go in and select our, let's do our handles. Doesn't matter what order we do these in. All right, now on the handles, they are going to be cut through, but I'm only going to be cutting halfway through on each side. So we're going to go ahead and rock a pocket cut with the, I could do a profile cut, right? And then just have those pieces floating in there instead of a pocket milling all that away. Let's do that. Let's do a profile cut. It'll be a little bit faster. And I'm only going to be cutting 3/4 of an inch through. 1/4 inch end mill. I'm going to be cutting on the inside of the line. And I'm going to add some tabs because there will be some, you know what? That is 3/4 of an inch wide. That leaves a 1/4 inch piece in there. Yeah, I'll add a tab. So the tabs, I'll just go 1/4 inch wide with them, and a 1/16 of an inch thick, because that'll make an 1/8 inch tab when I carve both sides and stuff. So we'll add those in, edit tabs, and I'll just put one here, one there, one there, one there. All right. Now that I've added those tabs, so those tabs will be present on the other side in the same exact spot and everything, I'm going to take a moment and I'm going to flip over to the other side, and I'm going to delete these two vectors right here. And then I'm going to take, from my front side, I'm going to take these vectors that have the tabs in them, and I'm going to copy them to the other side, and it'll copy the tabs along with them. How cool is that, right? Okay. All right, let's go ahead and calculate this. This is going to be my hand holes. And again, that's also 0.25 mil, so no bit changes so far. Awesome blossom. All right, and then I want to do a round over on the hand holes and stuff, as well as the outside edge. I'll probably round that, break that edge as well on that round over. So let's go ahead now. We'll do this bit, and then we'll do the round over bit last before anything. Well, let's actually create this profile cut halfway through. Well, let's I was trying to organize this where all the bits will be together. So yeah, we'll do that profile cut. Normally, guys, profile cut is always last if you're cutting all the way through. I'm only cutting halfway through, so it kind of doesn't matter what order it's in, but if you're cutting all the way through your material, profile cut is absolutely last. You don't want that anywhere at the top, middle, or anything in your toolpaths, because you don't want that board cut loose from its hold downs or what have you while you're trying to work. But I'm only cutting halfway through, so I've got plenty of meat still being held. So profile cut for that. Again, 3/4 of an inch thick, 1/4 inch end mill. This time I'm going to be on the outside of the line. We're going to add some tabs for this as well. This is going to be my outside profile cut. It's also a 0.25 end mill. And let's add or edit some tabs. And right here, there's not going to be anything here. And when this gets cut, there's not going to be anything here. When this gets cut, there's not going to be anything here. So the only thing that's going to be left standing are these 4 corners here. So I'm going to add some tabs in each of these 4 corners. Now, if you wanted, for whatever reason, to ensure that everything's rigid while it cuts through, on the other side when you do that final cut through and stuff, make your tabs wider, or thicker, should I say, wider and thicker, to give yourself a little bit of meat, right? Some holding power if you want. All right, so, but an 1/8 inch will hold just fine. All right, so with that, we're going to calculate this toolpath. Okay. All right. Now I'm going to take, once again, I'm going to flip over to the other side. I'm going to take this vector here and I'm going to delete it. I don't know why I didn't do all this why I did it in the beginning. But anyway, I want to copy this one to the other side because it has those tabs on there, right? We, copied the tabs over. Okay. Now, which one do I want to do? Let's do the trail and then we'll do the round over. So the trail, and then we got a drilling toolpath or a pocket toolpath here. Let's not forget our through hole or else the game won't be any good at all. Now, I'm also going to draw some small circles around here where I'm going to do a little bit of pre-drilling with a V-bit so I can pinpoint some holes where my plexiglass is going to get cut, because I am going to be using this vector here to cut out my piece of plexiglass and also pre-drill and tap the holes on the CNC. Now I could very easily, just cut this out, drop it in there and pre-drill and countersink the holes. Not tap, I said tap, but I meant countersink. And countersink the holes all with my handheld drilling stuff. But why not use it if we got it on the CNC? So let's get back to where we were. On our trail, I'm all over the map today, guys. Lord have mercy. All right, this is going to be a pocket cut. And my cut depth is going to be, remember, I got a 1/2 inch marble. I want this marble to be well underneath this plexiglass and everything. I want to be down in that groove, so I'm going to go 9/16. Okay, so 0.5625 in depth. I'm going to use my new handy dandy little form tool. And I don't need to do it in 8 passes. I can be a little bit more. That was taking a 1/16 of an inch per pass, but that bit's got a 1/2 inch shank. It can take a little bit more meat. So I'm going to do it in about 5 passes because I still want a clean cut and everything. So a little less than 1/8 of an inch per pass. And that should change my pass depth here. All nice and good. All right, so with that form tool, we're going to do a rast offset because it's just following the path. And this is my marble trail. And this is my 0.5625 box core bit. Okay. Okay. All right. So now that we've got that, now of course, if you didn't want a rounded bottom, guys, and you didn't have a box core bit and all that, you could absolutely do this with a straight bit, right? You could have just a straight pocket cut. We've given ourselves plenty of room on the width and everything that if we did use a straight end mill, if I used a 1/4 inch end mill to cut this and everything, you don't have to use a box core bit at all by any means. So you could do a straight pocket cut if you wanted to. All right, keep that in mind. I just wanted to let you know that, just in case you thought you had to have a round over bit or a box core bit to do this. Okay, so we got our marble trail. Now we're going to do our through hole. That's going to be a 1/4 inch end mill wheel as well, and I'm going to create the toolpath and I'm going to move it up in the list to keep all those 1/4 inch mills together. But let's go ahead and create it. This is going to be a pocket cut, and again, I'm only cutting halfway through on this side, halfway through on the other side. So we're going to go 0.75 and 1/4 inch end mill. This is my flip hole, flip to the other side. 0.25 end mill. All right. Okay. That'll create that hole there. And then now let's wrap it up with our round over bit. And for the round over bit, we're going to do, let's see, we're going to do the hand holes. And we're going to do the outside profile here. This will be a profile toolpath. I'm going to be cutting a depth of a 1/4 of an inch. I'm going to be using the white side 2050 1/2 inch round over bit. And I'm going to be stepping over 1/8 of an inch. Okay, I'm going to do this in one pass, and I'm going to have an allowance offset of 1/8 of an inch. Okay, and I'm going to be cutting on the outside of the line with an allowance offset of 1/8 of an inch. Negative. And this is going to be my round over. That's my white side 2050. All right, so we're going to calculate that. And I'm going to look in here, I'm going to look at my solid view and make sure I did round over and offset the correct direction, which I did. Wonderful. And so we can go ahead and preview that cut. Okay, and that's just going to give me that nice, oops, That's going to give me that nice round over, comfortable feeling, you know, look and everything. All right, now I believe that is all the tool paths for this side. So we're going to flip over to the other side. I wish there was a button where we could pretty much copy to the other side, right? You know, but there isn't. So we're just going to flip to the other side and recreate those toolpaths. Now there might be, I might be talking out my butt. Let me see here. I could create toolpaths. I could save the toolpaths as a template and then just import that toolpath template to the other side. That's one way of looking at it, but that's okay. We'll work from this side. All right, so first come is our pocket cut. Rinse and repeat, ladies and gentlemen. This is going to be 1/8 of an inch deep. We're going to be using our 1/4 inch end mill, and this is going to be our side 2 cover pocket, 0.25 end mill. We got our, first and foremost, our alignment pinholes. Let's talk about these alignment pinholes. These are going to be first in the list. Drilling operation. Now in this, these holes are not going to be cut on the other side of the board. They're going to be cut into our waste board. So when we're finished with side 1, we're going to move our board out of the way, unclamp it and move it out of the way, and we're going to touch off our Z on our waste board, and we're going to run this toolpath. Now here I'm only going to carve about 1/4 of an inch deep into my waste board, or 0.3, whatever you want to do. And I'm going to be using a 1/4 inch bit. I am going to peck, and this is going to be my waste board alignment holes. Now, here's something that you've got to keep in mind, right? Okay. Here's something you got to keep in mind. Bear with me a minute. This will make sense in a second. 0.25 end mill. We are calculating all of this based on touching off our Z0 being the bottom of our material, right? That 1.5 inches. So if we were to look at our job setup in here, our job setup is our board thickness is 1.5 inches, and our gap above material when we hit the start button where that router raises up to is going to be 0.8. So if we look at the total height, when I hit the start button, my router is going to raise up 2.3 inches. It's going to be my 1.5 inches from 0 plus that 0.8 above my material, the tip of the bit, and everything, for a total of 2.3 inches. It's going to be raising up. Now, I've got to drill. I'm working off the bottom of this material. That's my 0. Okay. Well, when I do my alignment pinholes, and everything, I'm touching off on my waste board. My waste board is 0. So when it's wanting to drill these 1/4 inch holes, it's wanting to do it on top of that 1.5 inch material, right? So we're basically, we are going to be setting a start depth of 1.5 inches on those alignment pinholes when you're working off the bottom of the material. Only when you're working off the bottom of the material. If you're touching off your Z on the top of the material, then your start depth is 0, right? Because when that router from 0, when it raises up to cut that 1/4 inch hole, right, it's going to be carving air, because there's not going to be a board there, because it's supposed to be drilling these holes in the waste board. So I need to start at 1.5 inches. or let's try this one more way, because that's how thick my material is. So basically, I'm carving at my 0 down 1/4 inch. Okay. This is only when touching off on the bottom of the material. We got to account for that. Okay. All right. So we're going to use a pecking motion, and we're going to calculate. All right. And those go first. So we're going to always do that first. So we're going to carve side 1, move the board out of the way, make sure that our Z is still zeroed out or touched off on our wasteboard, and we're going to run those alignment pin holes to drill those 2 holes in our wasteboard. We're going to stick our little dowel pins in them, whether we use shelf metal pins or wooden dowel pins. Now we're going to flip that board over and stick it down on those alignment holes and re-secure it, and then we're going to run, all of our side 2 cuts. Okay, awesome. All right, so now for my holes, hand holes, that's going to be a pocket cut, or profile cut. We're going to be cutting halfway through with our 1/4 inch end mill, and we're going to get to your questions, David, Jim, and Kim. Hold tight. We're going to get to those questions. Let me create this toolpath, then we'll answer some questions, then we'll create the other toolpaths. So 1/4 inch end mill. We're going to be on the inside of the line. We're going to add some tabs, and tabs are already there, so I don't have to edit them. And these are my side 2 handholds. 0.25 ml, and we're going to calculate them out, and we're going to pause for some questions. So let's go with David Kinsey. The story goes, all right, we'll get to the Dr. Pepper story in a minute. So we're going to go to Jim. I'll read that in a minute, second, David. I thought it was a question. Jim, what are the bumps in the marble path? What are the bumps in the marble path? That's the radius of that roundover bit. So what Jim is asking is, if we flip our board over here, and let's flip back over to side 1. Okay, so what Jim's asking is these bumps right here. This is where the intersections are meeting, and that's the radius of the bit when it's coming around and carving this and everything. That radius is coming up, and then there's a little intersection right here where these intersections meet. If we were to see if I can, let's change this to marble, or not marble, maple, so we can get that nice white look. And let's look at this. Let me hold down my control key so I can move over to the side. Okay, where that router is coming around and everything, that router bit and all, we have our radius, coming up the sides and everything. But there's a little curve radius right here, and then when this bit comes through and it stops at its stopping point, it curves as well, and it creates this little lip. But it's so minute that it's visible in the software, but you're not really going to see it too much inside of the cut. And if you wanted to knock it down a little bit, you could and all, but it's not going to create like a little ramp for the marble to jump and all that stuff. You're just seeing where that router bit is traveling and stuff, and you're going to see that at a lot of the intersections and stuff as well, and transitions and corners and all. Now, hopefully that answers your question, Jim. Now, Kim says, so if you didn't have a round over box core bit, the entire project could be done with a 1/4 inch end mill. Absolutely. So how would that look if we did it with a 1/4 inch end mill? So let's say that we take our path here, and we come over and create a pocket toolpath. We're still gonna cut that 9/16 inch 5625 9/16 inches deep with our 1/4 inch end mill, and this will be our sample marble pocket. And we'll go ahead and calculate that out. And let's reset this preview, and let's do our alignment pinholes, cover, our hand holes. I just realized something. I got to recalculate one of the tool paths, the sample marble and also my regular marble. They've got to start at 1/8 of an inch down. Remember, we're pocketing, right? We're pocketing down 1/8 of an inch. So let's real quick do that. This needs to start at 1/8. I'm glad I had to go back and look at that. All right, so let's see here. Marble trail, we don't want that one. Flip hole, that'd be good. Okay, let's preview the visible toolpaths. So Ron comes back while we're previewing this. Ron comes back and says it's a good idea to merge the toolpaths that use the same bit in a project so you can avoid stopping and restarting. Well, Ron, let's change the wording a little bit on that instead of the word merge, right? So when we are saving a toolpath, and sorry, real quick, Kim, there you go. Absolutely perfectly fine to use a 1/4 inch end mill for your marble maze. That's how we made our last one, you know, with a straight end mill. So that's what that would look like. Ron, so saving, if I take all of the toolpaths that use the same bit, okay, that use the same bit, and when I'm saving a toolpath, I can output all of those toolpaths to one file, so it's just one file running, okay? If I merge the toolpaths, if I have to go back and edit a toolpath, you cannot edit a merged toolpath. So I don't want to merge my toolpaths together as one that use the same bit. I want to save them as one file to run them all together, so I'm not starting and stopping. But I don't want to merge them, because if I have to go back and make an adjustment in my toolpath, change the start depth or the offset or whatever, then I can go back and do that. But if I merged them, I cannot go back. So let's take a look at what that would look like. I'm going to create a second toolpath here. I'm going to edit these. I'm going to duplicate this one here, this sample one. Okay, and if I take these two toolpaths here, let's uncheck all of these. If I checked off these two sample toolpaths here, and I merge them, okay, my sample merge pocket 1. I don't know why it's and order in which I want to start carving from on that merge toolpath, and save this as my sample merge. I don't know why there's 3 listed in there, probably because I checked them and everything. But if I merge those toolpaths, okay, so now I have this sample merged, and if I needed to go back and edit it, I can't, you know. So then I would have to go back into my individual toolpaths, recalculate or readjust them, and then re-merge them. Why? That's a redundant step. Why? If I can't do anything with it, if I can't edit it, if I can't fix it, if I can't do anything, why have it there? Because, you know, if I need to go back and edit my toolpaths, I go back and edit them, and I just save them together as one file, you know? So let's change the wording on that from merge. It's a good idea to save all the toolpaths as one file so you don't have to start and stop. Not a great idea to merge them because it's kind of redundant. Hopefully that helped. Okay, let's get rid of those. All right, let's go to the other side. And now, keep this in mind. I don't have all the answers and all that. That's my opinion. There may be a specific reason for merging. That might be required to merge in order to save as a template, whatever the case may be. But for me, it's not a good idea to merge the toolpaths. It's redundant. If I have to go back and make a change or something in that toolpath, then I still got to go back into my originals, change them, and then remerge. And then what do I do with this merge? Just delete it, right? So then why create it to begin with? Okay. All right. So we've got our handle holes. Let's go back in here. So we did our handle holes, our profile. That's going to be last in this one. We're not doing that one together. That's the final cutout. So we did our handle holes. Let's do our drill hole, our pocket cut for our through hole, should I say. This is going to be 0.75, 1/4 inch end mill. Offset's fine. This is going to be my side to flip hole, 0.25 end mill. All right, we're going to do our trail. And I got to calculate. Remember, remind me to go on the other side and recalculate my trail toolpath a little bit deeper. It's got to start at 1/8 of an inch, because remember I pocketed down 1/8 of an inch for the plexiglass. So remind me to do the other side when I flip back over. 0.125, and I'm cutting. Well, since I'm starting there, I don't need to go the full 3/4 all the way through, because that'll cut my tabs out. So we're going to go 0.625 on this one. Yeah. And no, I'm sorry, this isn't a cut through hole. That's my marble maze. 0.5625. There we go. Going to use our box core bit, and we're going to reduce the passes. I don't need to go 8. I'm going to go 5 passes. Click OK. Oops, shoot. Yeah, there we go. This is my side to marble trail. 0.5625 box core bit. All right. Okay, so let's take a look at what we've got here. We've got our wasteboard alignment holes. They'll be cut into the wasteboard, so they won't be cut on this side, so I'm not going to run them. If we preview our visible, we've got our hand holes. We've got our through hole. We've got our cover pocket that for the plexiglass cover. And wonderful, wonderful, wonderful. Now we need our, I'm going to do the round over here and over here. So I'm going to do this round over is going to be separate because it's already cut out. I'm going to do 2 toolpaths with the round over bit. This one's going to be cut out already with that 1/4 inch end mill. It's going to create that relief cut, right? So I'm going to come in and I'm going to just select those 2, and I'm going to do my profile cut on the inside of the line. I'm going to go 1/4 of an inch deep, and it's doing it in with my 2050. It's going to do it in 1 pass, and this is going to be my hand hole. Round over. with my white side 2050 bit. Calculate that. And then I'm going to do the round over on the outside edge here separately, because I'm going to, instead of taking a full 1/4 inch plunge, I'm going to do it in 2 passes for a nice clean cut, and instead of one big pass. So we're going to do that same thing. We're going to create another profile cut, and same cut depth and everything, except for I'm going to edit my passes, and I'm going to increase that to 2 passes, and I'm going to go ahead and click OK. And this one's going to be on the outside, and this one is going to step over, and I need to go back and fix my step over on the other one as well. We're going to go negative 0.125, 1/8 of an inch, because it's going to bring that round over bit over to do the round over. And this is just going to be my side 2. I got to put side 2 in the name of the other one too. Outside round over. My white side 2050. Let's calculate that, and let's go back and do a little bit of cleanup. We're going to go back into this hand hole round over and edit it. I need to step over, okay, that 1/8 of an inch, and I think that's all I needed to do with the cleanup. So if we preview those 2 toolpaths, and that way this one here, because it doesn't, we don't have a relief cut, you know, with the end mill cutting it, because our profile cut is getting cut last on this. I wanted to step that 1/8 inch bat down, or that round over bit down in 2 steps to do that round over to get a nice clean cut, because I'm going to be taking more meat. There's more material there because it's not been milled away by my end mill and all. So, all right, and then finally, our profile cut, our final profile cut, and then we're going to talk about the plexiglass covers here. So let's close this and do our final profile cut outside of the line. We're going to be cutting 0.75 inches deep with our 1/4 inch end mill. We're going to add tabs. Tabs are already there from where I copied them over to the other side. And this is side 2, final profile, 0.25 end mill. All right, and we'll preview that cut. And then Ronnie Probert, I'll answer your question on how long it'll take to carve this in just a second. We'll look at those times. Ron jumps back and says, makes good sense, thank you. If you have 3 toolpaths using a 1/4 inch end mill and you run the first toolpath, when it finishes and the router returns to the home position, is it necessary to touch off before the second toolpath? No. Now, Ron, we just talked about this one. So if you have 3 toolpaths using the same bit, okay, you're going to save them together as one file. You're going to output them as one file. And when it saves them, it does not return back home till the end of the job. It's going to run all of those cuts, and then it's going to go back home. So you're only touching off and setting your Z one time, okay? And then you're going to run that file that's going to run all of these toolpaths that use the same bit. And let me get everything checked off here. Okay. And it's going to run all of those files. It's going to start with the alignment holes, move right to the cover pocket, right over to the hand holes and right over to the flip hole, and then it's going to come back home and shut itself off and stuff at the end of that. It doesn't run one then come back home, run the second one, come back home, run the third, come back home. It doesn't do that. It runs all of them together as one file. So think of it as almost like merging, but you're not, right? They're not being merged. They're being saved as one file to run. So you don't have to touch off before the second path or anything. You just touch off at the beginning and run that entire file that runs all those toolpaths. Now, if this was a tool change, of course, when it does come back home, we take that bit out, put the next bit in, and yes, we do touch off our Z before we run that next tool. Awesome. Good question. All right, let's see here. All right, so let's go back and let's preview all of our toolpaths together, and let's see if we missed anything. Preview all sides. And then we're going to talk about the plexiglass and how we want to do that, and then we're going to wrap her up. And you're welcome, Ruth. Oh, shoot. That 1/4-inch end mill is still in there. All right, I'm going to stop this for a second. Side 1. Let's go to side 1. I'm on side 1. Am I on? Yeah, let's go to side 1. Oh, no, I deleted it. I thought it was in there. All right, side 1, I do need to change my marble trail. It needs to start at 1/8 of an inch and then cut down 5, 9/16. So calculate that one more time. Now let's go througand preview all sides. Sorry about that. Somebody was supposed to remind me to fix that. All right, any questions, guys, while we get done? Because the last thing we're going to do is we're going to talk about our plexiglass cover and everything. But if you have any questions, now would be the time to ask. All right. Almost done with the preview. Now on side 2, you will see the alignment holes cut into side 2 of the board. They don't get cut into the side 2 of the board. You're just seeing them there because I ran all toolpaths. I clicked the button to previews all toolpaths, so it's just previewing all. But now, do you understand what I meant? Let's get a show of hands. I need everybody to confirm they understand what I meant about the alignment pin holes for the wasteboard for side 2. When we're finished with side 1, and we take that board off the table and we make sure our Z is still touched off and zeroed on our wasteboard, because that's what we're working from in this particular setup, my setup. Why we set our alignment pin holes for the wasteboard to start at 1.5 inches. If you understand what I mean by that and why we did that, give me a yes. If you're still a little confused on it, give me a no. All right. So there's our board. We got our cool little through hole and stuff. Didn't do any V carving yet for the start and the finish line and you're a hero, whatever we're gonna put there and stuff, and all. And from our top view, if we look at it from the top down, you can see those intersections, around the corners and stuff, and everything a little better and all. And that's our center line. Again, you don't hardly see it at all. And what that is it's a pocket cut, right? So if we look at the toolpath, the marble box core bit toolpath, if you look at that, guys, what those little things are is that router bit is coming and it's cutting here, you know, all the way around, and then it's circling back. You know, it's a pocket cut, so it's circling back and everything. And when it does, and it creates that, you know, that back pattern, when it turns this corner and all, it creates that little hologram of let's turn that off so you can see it again. These little divots, and if you wanted to, it's super minute, super small. If you wanted to clean them up, you could. You know, so we're like 0.8128 versus let's get there, 0.8195, 0.8377. So like 20 thousandths of an inch, 10 and some change and all. Now, if we wanted to remove them, right? If we wanted to remove them, what if we took our marble trail, here, we're going to have intersections there and all. This is just a hypothesis. I'm not saying do this, but let's check. If I run a profile toolpath on the line with my box core bit, and I preview that selected toolpath, you know, we end up with, let's see how we can look at this. We end up with these little ramps and stuff. So don't recommend that at all. That'd be a whoop-de-doo. That's a motocross track now for that marble. It's no longer flat. So don't do that. I just wanted to see what would happen if we did. All right, delete that. All right. So Jim just it's just small little divots that can be cleared out. Okay. So excellent. Now let's talk about real quick. Let's talk about our plexiglass cover and everything. Let's turn that marble trail off and let's turn on our vectors and all that stuff. Let's turn that off. We just need these two vectors to focus on right now. Now, I'm going to I could just create another project and copy this vector over to that project for cutting out my plexiglass, but what I'm going to do is, this is already on its own line. These two vectors are here. So I'm going to turn off my outside profile. I'm going to turn off my handles, and I'm going to turn off my dimensions. My alignment pinholes will stay there. That's not a big deal. They're not going to be there in this second cut anyway. But I'm going to take on these here, and I'm going to figure out if I want to do some little pre-drilling in my wood and stuff with a V-bit just to pinpoint where the holes are going to be, so I can use a pre-drill. I could just cut out the sheet, stick it in that pocket, and then pre-drill, countersink, and add my screws, right? Very simply, and do it all by hand. But if I want to do it on the CNC machine, then I need to lay out my hole pattern, okay? And then I need to prep and move these vectors in a place where I can cut this sheet out working from the bottom left corner of that material, okay? So I can just put them where my jig is, and stuff. So first things first, let's create a little hole pattern. I'm going to be using an 1/8 inch end mill. Oh no, what's smaller than an 1/8 inch? Because these little brass screws are not going to be an 1/8 of an inch. Oh, I wish I would have measured them out in the shop so I could be exact. We'll use 1/8 of an inch, but I will, before I put these plans out, I will tell you the part number of the brass screws that I got from Lowe's, and then the actual diameter of the pre-drill holes. I'd most likely be using a 1/16 inch end mill, and let's do that. I'm going to go 0.63. Okay. And so there's going to be and I don't want to be snapping these holes to this grid. So for right now, I'm going to turn the grid off. Okay. And so I'm going to place a hole here. And now I got to figure out how far apart I want each hole. I'm only doing one side because I'm going to end up mirroring them over exactly the other side. Let's move this line relative. Right-clicking on your guidelines will open up the properties for those guidelines. We're going to move relative, the guide relative, and I'm going to go 2.5 inches. Oh, I was so close. All right. So we'll move this one right there. All right, and this one's going to be centered down here. And then let's open up our circle tool again. And let's go right in the center. Not up there in the center, you goofball. Right in the center. All right, so now I'm going to take these vectors here. Oh wait, let's go snap to there and move this one relative 2.5 inches down, negative. So I can put okay, now I want all of these holes except for this one. This one's, you know, but I want these holes to be in alignment with each other. So I'm going to select this one here. I'm sorry, this one here first, and then this one last. And in my alignment tools, I'm going to use this first button here to pull them into alignment with one another. Okay, so I'm going to take these vectors here, or these here, and I'm going to mirror them. I'm going to mirror them flipping about job center horizontally, but I'm also going to mirror them vertically and then horizontally again. Okay, now by doing that, I've created duplicates on the center circle, so I'm going to delete that extra one that I made there, and here as well. When I select on it, delete that. All right, and then also up here in this center. Don't want to see a solid line when I click on it. I want to see a nice dotted line when I click on those vectors. If not, then delete that, you know. So I'm hitting the delete key after I select on them. All right. Yes. So David asked a great question. David Kinsey asked, would the screw information be a good candidate to put in the notes section of the project? Yeah, I mean, you absolutely could, you know, especially when it comes to the part of the toolpath and all for cutting out the plexiglass lid and everything. Now, so good question, David. Yes, that would be a good place for them. Now, not only do I have my perimeter holes and everything, but I also want to put some holes, some screws just to screw down the center area so it doesn't flex or cup or bow or what have you. Not cup, but bow. So I'm going to turn my marble trail machining back on, toolpath back on, or flip holes. Actually, it got moved on me. Let's fix that. Got to keep our layers organized properly. So this is going to be moved back to the marble trail machining layer. Okay. So these areas here in between the trails are my walls, right? So if I were to, that marble shell bit, if I were to fill this in, all the white areas are my walls. So I want to put some holes in here where the lid is going to get screwed down to. So let's see here. I definitely want one in here somewhere. And let's see, we'll go kind of go right down the middle right there. And doesn't need a whole lot, so we'll go kind of right here. And what I'll do is I'll realign that one in just a moment. This will be fine there. And it doesn't need a whole lot, so we'll go here and there. All right, so on these two holes, I'm going to take and select this one down here, and then I'm going to select, I'm going to select this hole, and then this one last, and I want to align to that last selection. Okay, so I wanted those holes kind of in alignment there. This one I'm not going to put into alignment unless I moved it over here instead of there, but I want it there. And this one here, I'm going to take and select it, hold down my shift key and grab this one, and I'm going to line up and down, and it's already in alignment there. And this one I'm actually going to move to right about there. So just a couple of places, probably should put one up here. They're not real big screws. I don't want any flopping or anything like that, so I probably should put one kind of strategically place it, and I'll place it in line with this one. So what I'll do is with that selected, I'll select this one last down here, use my alignment tool and align it centered left and right. Where are you going? Where are you going? Hold on a second. That sucker went in the whole opposite direction. Let's try that one more time, said the jelly bean. Okay. So with this one selected first, hold down my shift key and select this one last. Why are you shooting? That's not in alignment. Is it in alignment or am I just going blind? It is in alignment. Hold on. I got to test that theory because it looks like it's way off to the left. Nope, that's in alignment. Shoot, man, my eyes are crooked. From back there, you tell me that doesn't look like it's going off to the left. All right, so yeah, that's alignment. Okay, so there's my holes. These are going to be my holes for pre-drilling, so I can turn off that marble machine area there. I can turn off that toolpath. That toolpath, by the way, to get that blue fill, I'm in solid view. So we got a wireframe view of where our router bit, the center of our bit's going to be cutting, or we have solid view. And I filled in that solid view just so I can see where I could put my holes. Okay, so we'll uncheck that. All right, so this is going to be my hole pattern for in there. That should be good. I don't need one up here. That's good. That's good. I don't want to go too crazy with the holes. So let's go ahead and first off, these holes are going to be, we're going to use a V-bit. And we're going to take that V-bit and we're going to just cut like a little 1/16 of an inch to create a dimple in our wood where that we need to pre-drill. Or, see, I don't want to, no, I want to use the dimple because I want to use the small bit that I got for the screws. I don't want to use my 1/16 inch end mill and then it be too loose, you know, because they're real small brass screws, you know. They're long, but they're skinny. So I'm going to use the V-bit for this. So we're going to go V-bit. It's still a drilling operation, but it's going to be a V-bit. I'll use my 60-degree V-bit. I'm only going down just a 1/16 of an inch. Yeah, 1/16 of an inch. That'll be good. Just to create like a little little divot. And this is going to be my lid screw hole placement. 60 DEG V-bit. And this is going to be actually cut in the wood. So we'll calculate that. And so that'll be in the wood. That's where the hole placement is going to be. Now, what did I just do again? If we look at the cover cutout, right? The cover pocket cutout, what did I just do? Right? Those holes are going to be gone. Right? We gotta remember, always remember that pocket is being cut down 1/8 of an inch. So those holes, those lid screw placement holes, need to start at that 1/8 of an inch. Okay? And you know, and then cut down our 1/16. So that's going to be our little placement in our wood where we're going to use our little drill bit and pre-drill. Okay. Now, for the actual plexiglass, everything is going to get moved here for a minute because I'm not going to create a whole new project just for the plexiglass lid. I'm still going to use this project board area here, but I'm going to move these vectors or make a copy of them and move that copy over to where the corner is on the bottom left corner here where it would sit in my jig. So my sheet, this outside area here is 13 3/8 by 8, and my sheet is actually going to be I think it's like 10 by like 15 or 16 or something like that. So this is going to be cut out of that sheet, so it'll be all good. All right, so what we're going to do is we're going to select all of these holes and lines and everything, and we're going to make them a copy to a new layer, and this is going to be my I'll just call it acrylic. I think I'm going to use plexiglass though, but my acrylic cover part cut layer. And I don't need, I don't know why I'm doing no spaces for the layer name. All right, and these are going to be, I'll go, we'll go orange. All right, now I'm going to turn off, come into my layers, I'm going to turn off the originals, right? Get rid of them. And I'm going to make this part cut out active, because this is going to get moved. We're going to group it together, and we're going to move it to an absolute position of X, the bottom left corner, should I say, of X0, Y0, okay? Because when it sits in my jig in that bottom left corner, that's where it's going to sit. Now, the one thing that I have to be mindful of is that, you know, if I wanted to give it a little bit of room, because my part is going to be like 15 by 10 inches, I could, but I'm just going to cut that out, which will leave my scrap cutoff here. If I was worried about cutting down and being, you know, when I'm cutting on the outside line of my fence, I could put a spacer, or I could just move it up to what it is, because the part itself, the actual real part, before cutting, is going to be 15 by 10, the actual sheet. And so that part is going to be up against the fence. So if I wanted to take these and I wanted to move them up relative, we'll move it over 1/4 of an inch and up 1/4. You know what I mean? You with me on that? You guys with me on that? This is my actual plexiglass sheet, and then this is the part that's going to be cut out of it. And I'm starting from 0, 0. So, all right. So the first thing that's going to be done is we're going to ungroup this, and we're going to take just our holes, and those are going to be drilled. There's going to be a drilling pattern with our 1/16 inch end mill, and we're cutting through all the way through the material, 1/8 of an inch. With a 1/16 inch end mill. I've got an Amana 1/16 inch end mill, and I've got it, but I don't have it in this particular metric, so let's create it. End mill 0.0625, 0.03125, 40%. 45 and 15. Okay, there's the parameters that I set for my 1/16 inch end mill, and we're going to use pecking. And this is going to be my plastic acrylic, whatever the heck we were going to use. I still don't know what it's called. It's Lexan. I think that's acrylic, but it's extruded, so it's not cast acrylic. But it might be plexiglass. I'm not sure, but it's Lexan, or if that's its own thing. But anyway, acrylic hole drill. And that's my 0.0625 end mill. Then I'm going to take that same hole pattern in the plexiglass, and I'm going to countersink. I'm going to use my drilling operation again. This time I'm going to go down, I believe it is I want to say it's going to be like a 32nd, but I'm going to go 0.05, 0.05, not a half inch. I think it's a 32nd. I got to look at the heads and see how they are, but they're small. It's a super small brass. But I'm going to be using my 90. Could use my 60. They're small enough for the 60. Generally, I'd use the 90, but these are small enough for the 60. No, I'm going to use the 90 because I don't want them to be that deep. I just want them to be countersunk. So we're going to calculate that. Click OK. This is going to be my countersink, my acrylic cover countersink. 90 DEG V bit. And I may, so I can use, yeah, that's good. So if this were my plastic cover here, let's reset so it looks like a blank board. And let's really get into it, blue plastic. All right, so this was my piece of acrylic. How about pale blue plastic, not solid blue? All right, and I preview those, that cut. So I've got the countersink and then the drilling operation. Now that countersink is countersink's not that big, so I need to go deeper with that. I don't want to go the full thickness. Bear with me a second. 0.06. Unless I'm just... Oh, I'm not zoomed in enough. Okay. Sorry, I wasn't zoomed in enough. Alright, so I do need to go a little bit deeper. There we go. There we go. So that's going to be my countersink cut with the 90-degree V-bit. And then my profile cutout. This line again is not being used. We can actually, this is our copy here, so we can delete that. So my profile cutout, I'm going to cut 1/8 of an inch deep, the thickness of the material. We're going to use our 1/4 inch end mill. And we're going to be on the outside of the line. Not going to do tabs on this one because I want a nice clean cut, so I'll probably end up using some double-sided tape. All right, so we'll cut that out, you know, that would be out of our acrylic, and that will be our lid. Okay, now on this, guys, I want you to know something once again. The way I just did this, if I was touching off on the top of the material, everything is hunky-dory, okay? But I'm touching off to the bottom of the material, right? So I'm not going to have this plexiglass sitting on 1.5 inch block of wood, right? I'm not going to have a 5/8 block of wood underneath it as a wasteboard type of thing. I've got my jig as my wasteboard. So if by doing this, by me creating these toolpaths in this project, I'm not doing any justice to you in the learning experience because the toolpaths are incorrect as they sit right now. I would have to be starting on my start depth. I'd have to be starting at, you know, in a 5/8 inch down, or, you know, 1 inch and 5/8 down or something, and all that for the toolpaths to be accurate. So what I'm going to do here is I'm going to save this job, and this is going to be my marble maze, and this is going to be for the woodworking shows. Once that saves, and I have a master copy of it, I'm going to now come in and save it again. This time is going to be the Marble Maze acrylic cover. So now I've got both my files. I've got my Marble Maze and my Marble Maze with acrylic cover. And so now I can come in and I can go into here and actually set this one up. This is for the acrylic cover. I can set this job up properly. Okay. My sheet's going to be 15 by 10. And I'm still everything, it's a single-sided job for the lid, or for the plastic cover. Everything's the same as far as I'm still touching off on the wasteboard, still starting from the bottom left corner. It's going to say, this is going to delete all your data on your opposite side. Do you want to continue? Yes, because I don't need it. Okay. I do not want to calculate my toolpaths right now because none of these toolpaths for this particular file, copy of the file, is relevant. So I'm going to delete these visible. Okay, so I just have my acrylic and everything. And now we can be proper. And everything is fine with my toolpaths and all that wonderful stuff. And now I have two files, one for the plastic cover lid, one for my actual marble maze. So that is the correct way that we should do it. We should have two separate files. By me creating those files in that one file would have been fine if I was touching off on the top of my material, because it doesn't matter, the top of the acrylic or the top of the piece of wood. But in my setup, I'm touching off on the bottom of the material, which means those three toolpaths that you see here were incorrect. Starting at 0, cutting down to this, well, I'd be cutting in the air, and you'd be like, well, why is it cutting in the air? Because it was set up for the the wrong thickness of the material, the wrong size of the job. So this should be proper here. So we have two separate files now, one for the Marble Maze acrylic cover and one for the Marble Maze itself. So let's preview all the toolpaths. Oh, let's take all these guys here and let's recalculate all of them. Okay, and let's make sure our job is set up properly. Okay, everything's set up properly, and preview all the toolpaths. I'm going to be using double-sided tape for this, so I'm not going to use tabs and everything, but that would be the acrylic lid. Okay, so we've got our file for our acrylic lid, and wonderful stuff. All right, now let's save this one, save the changes we made to this. We've saved these toolpaths at a later date. And with that saved, let's open our marble maze, the actual wooden one, the marble maze part. Okay, let's go ahead and delete these vectors. They don't belong in the marble maze. They were for the lid. We're going to clean up and delete that layer. And we're going to come over and on these three toolpaths right here that we made for the acrylic lid, we're going to delete them. They're not for this job. So now we should, if we preview all the toolpaths for our wood part and everything, we are 100% done with this job at 10 o'clock later. Okay. So we're going to wrap this up right now as soon as this does its preview. So while it's doing its preview, if you have any last questions, now is the time before we say goodnight for the evening. And I want to thank you if you stuck with me this long. If you stuck with me from 7 to 10 o'clock. Awesome on you for learning this. And hopefully I didn't confuse you on that last part. But if you have any questions, now's the time to do it, to ask it. Because we're going to say goodnight as soon as we preview this. All right, so let's preview the other side. And while you're typing in your questions, and then we're going to call it a night. Now, this file, both files, one for the acrylic lid, one for the maze itself and everything will be available. We're going to make the file available for, we'll put the description in the YouTube channel for you guys and girls that are not part of the Digital Woodcarver Owners Group. And then also for you guys and girls that are part of the Owners Group, we'll put, sorry, I got the hiccups now. We'll put those files in there as well. Now, one of the things that you'll notice here is on side 2, we're missing the hole placement on side 2. If we flip side 2 over, we're missing the hole drilling placement and everything for the holes. And the reason why I didn't create the toolpath for them is because I literally just took the maze from side 1 and moved it over to side 2. You may want to be a little creative and create your own maze, which means that the hole placement for the island area is going to be different, right, in here. The outside area is going to be the same and stuff, but not the inside area. So we can still, if I copy the let's get back into the 2D view and turn everything back on. If I copy the hole placement to the other side and I create the toolpath for them, the island holes, if you're redoing this, it's not going to be the same, because I highly encourage you to create a different maze pattern on the back end. You know what I mean? Don't be the same. I just did that for time's sake. I'd probably do a little bit different maze, a little bit different path and all. But we're still going to create our little drilling toolpath with our 90-degree V-bit. I'm going to use my 60. I don't want my 90 hitting my wall. 60-degree V-bit drilling path, and this is just the cover hole placement. 60 DEG V-bit. And if I calculate that and we preview that toolpath, we should have our holes on. Oh, got to start at 1/8 of an inch. Start at 1/8 of an inch, ladies and gentlemen. We got a pocket in there. Always remember that. All right, we should have our hole placement on the back side as well. But remember, these holes in here won't be in the right area if you do a different maze pattern on that back side, which I encourage. But that's totally up to you. These files will be available for you to play with and download and all that stuff. But overall, guys, this is going to be our marble maze. It's going to be it's a simple maze. There's not a lot of complexity to it. As far as the trail itself and everything, just fun to kind of play around with, to have on the coffee table or something. But hopefully the concept, how to make your pass and offset that trail, to create your two lines, closing off, how to close off those lines and use your radius tool, your fillet tool, should I say. Hopefully all of these little tips you can take into other projects and stuff for the future. And I want to thank you for sticking with me till 10 o'clock at night. And let's make sure that... Oh, how long for the project to carve? How long does it take for this project to carve? Everyone is asking. So if we look at our time... well, here, let's see if our summary sheet... Create a job sheet... And let's see if our job sheet will show us the entire time of both. I believe I'm running a 2440 with a rapid rate and everything. So I think my summary sheet should show me both sides. If I open it up. Huh? Why would you... You're not supposed to be there. Don't you be a pain in the butt. Alright, we won't use our summary sheet. We'll just do it the old-fashioned way, because Microsoft Edge being a pain in the butt. So let's look at side 1 and check off all of our toolpaths and open up our clock. So side 1, you're looking at a total run time of about 2 hours, 40 minutes. That's based on my speeds and feeds, my past steps and everything. Okay. And oh, that's side 1 and side 2. So it's showing me everything for both sides. So the whole job, start to finish, is 2 hours and 4 minutes. 2 hours and 4 minutes. The longest run is 25 minutes long, which is 25 minutes long is the side 2 cover pocket or pocket cuts. Those are the only 2 long ones, 25 minutes long. Then you're 22 minutes, 7 minutes, 2 minutes, 34 seconds. So, not bad. Total run time, start to finish, both sides, 2 hours and 4 minutes. Ronnie Probert. And as far as the cover, if we look at the cover, the acrylic cover, that job by the way, this job, 1/4 inch end mill, upcut or downcut spiral, upcut preferably. 2050, white side 2050, 1/8 inch roundover bit is one of the tools that we're using in here. The Amana 16th inch ZRN coated end mill is the second one. Another bit that I was using in here. And then the Amana box core bit. And that box core bit is, if you're interested in it, is a tool number 45934. Amana tool number 45934. But a 1/4 inch end or an end mill. You can use an end mill too. Our run time for our acrylic lid, 3 minutes and 14 seconds. So you got 2 hours and 4 minutes on one, 3 minutes on the other. So about 2 hours and 10 minutes start to finish this entire job. You could knock a bunch of these out for Christmas, you know. So I'll make these parts available for digital download this evening. You will have them. They're available for digital download this evening. I will make them available. I'll put a link in the description of this video, the YouTube video down below. And then for you Facebook guys and girls that are in the Digital Woodcarver Owners group, I'll put the files in there as well. Now, with that being said, I've had a lot of people ask about how to join the Digital Woodcarver Owners Facebook group, and that group is a private group just for owners of digital woodcarver CNC brand units. So if you are a customer and you own a digital woodcarver CNC machine, go to facebook.com. In the search bar, type in Digital Woodcarver Owners Group. Click Join and answer the 3 questions: what model number you have, how long you've had it, and what you use it for. Submit that, and then I'll approve to get you in. If you're not a customer, guys and girls, unfortunately, that group is not open to the public. All right, so keep that in mind. We may start a page, a Spindle TV page, right? So anybody can get in and talk about different things. Sounds good, right? Spindle TV group. All right, ladies and gentlemen. Until next time. Thanks for joining me, and see you soon. I want to thank you for joining us tonight on Spindle TV, your best source for CNC CAD/CAM training videos. If you're watching Spindle TV on YouTube, be sure to hit that thumbs up button and subscribe. You can find out more information about our training and products by visiting us at www.digitalwoodcarver.com.